Hi, and today we will be going over the 2007 AP Calculus BC free response question, number 3, all three parts A through C. So let's get started. The graphs of the polar curves r equals 2 and r is equal to 3 plus 2 cosine theta are shown in the figure above. The curves intersect when theta is equal to 2 pi over 3 and theta is equal to 4 pi over 3. So what I would do first, if you have the time, is plug it into your graphing calculator, just so you can get a better visual of it, because sometimes those pictures aren't exactly accurate. I already put it into the y equals here, and let's take a look at the graph. There's our graph. So our graph, you can see the little dimple. It's got the area in between the curves there, which is going to be what we're going to want to do for A. All right, so A, it says let R be the region inside of the graph here of r equals 2, and inside the graph r equals 3 plus 2 cosine theta as shaded in the figure above. Find the area of r. So, looking immediately right here, I see that we can take this circular part and break it up, but unfortunately it is not a half circle, as would be probably one of the bigger mistakes on this exam. It's a mistake I actually made while going over this problem before I took this video. Since it intersects at 2 pi over 3 and 4 pi over 3, so like there and there, this is not actually a half circle. This is actually a 2/3 of a circle. So when we want to plug in our area equation, we want to break this up into a 2/3 circle and a polar area. So we have area for 3 part A is going to be equal to 2/3 pi 2 squared, because the radius is 2, because this is the inner circle, plus 1/2 integral from 2 pi over 3, 4 pi over 3, those were the given bounds, of 3 plus 2 cosine theta squared, d theta. So that is the equation you will want to be using for part A. Now, if we plug that in our calculator, we're going to get 2 divided by 3 pi times 4 plus 0.5 times integrate 3 plus 2 cosine theta squared, comma, theta, comma, 2 pi divided by 3, comma, 4 pi divided by 3. We're going to get 10.3705, and that is the correct answer. Area equal to 10.3705. So that would be the correct answer for A. Now let's take a look at part B. Part B. A particle moving with non-zero velocity along the polar curve given by r equals 3 plus 2 cosine theta has position x of t, y of t at time t. That's a mouthful. With theta equal to 0 and t equals to 0. This particle moves along the curve so that the derivatives of the equations dr over dt and dr over d theta are equal. Find the value of dr over dt at theta equal to pi over 3 and interpret your answers in terms of the motion of the particle. Okay, so basically what we have to do is just take the derivative of this equation right here, because we took the derivative of this one. It's equal to 0. It's also not even what is being asked, so just watch out for that as well. Take the derivative of this equation and plug in pi over 3 for theta. So let's take out our handy dandy calculator, get out of that. So we want to differentiate 3 plus 2 cosine theta, oops. That's going to be equal to negative 2 sine theta. So we know that dr over d theta equal to negative 2 sine theta. We know at theta pi over 3, I'll just plug that in because I don't remember radian circles, and I don't want to draw out the triangle. It's going to be equal to negative root 3. Now we have to interpret that in terms of the particles, sorry. So we know that the particle will be moving closer to the origin because dr over dt, since dr over d theta and dr over dt are equal, dr over dt is less than 0 and r is greater than 0. So therefore, it will be moving closer to the origin. So the particle will be moving closer to the origin because r is greater than 0 and dr over dt is less than 0 when theta equal pi over 3. And that is part B for you. Let's take a look at part C. Part C is going to be basically the same question with a little polar twist to it. For the particle described in part B, dy over dt is equal to dy over d theta. Find the value of dy over dt at theta equal pi over 3 and interpret your answer in terms of motion of the particle. So basically the same question. It's just with a little polar twist, as I said before. So we know from our great vast knowledge of polar, y is equal to r sine theta. Now we want to plug this in with our original polar equation, that one. 3 plus 2 cosine theta sine theta. Then we want to find dy for dt. Oh, over d theta, my bad. And that is going to equal, with our handy dandy calculator, keep hitting 2 for some reason. Parentheses 3 plus 2 cosine theta, close parentheses, times sine theta, theta. That's going to be equal to this really long thing. And we're going to write that out. So it's going to be 4 cosine squared theta plus 3 cosine theta minus 2. Now we want theta at pi equals 3. And that one's going to come out to, if we plug that back in with our calculator, buttons, 1/2. So the answer is 1/2 there. Now we have to interpret it in terms of the particle. So we know that the particle will be moving away from the x-axis since dy over dt is greater than 0 and y is greater than 0. So the particle will be moving away from the x-axis because y greater than 0 and dy over dt greater than 0 at theta equal pi over 3. So this is the correct answer for question 3 from the 2007 AP Calculus BC free response. The only thing I would look out for really in this problem, because it's pretty straightforward, is that this is not a half circle, this is a 2/3 circle. That would be the only thing I would look out for on this problem. Thank you for watching.